Hi, everyone. Thanks, Will. So I'm going to talk a little bit about the life cycle of an outage. First, I'm Scott Sanders. I work on the operations team at GitHub. So we're all here at Monitorama, and it's really awesome to see everyone in one place focusing on something that's so important. And I'd like to talk a little bit about the outage lifecycle and how our monitoring and our alerting tools can be woven into processes that enable confidence. So when an incident occurs, we typically have an increased risk of an outage. How we structure our initial response, our decision-making process, and our communication directly affects the impact that this incident will have. We need to think critically about our ability to quickly resolve any problems and reduce the risk of future incidents. So it's really awesome to be an operations engineer right now, because we've got better tools than we've ever had before. But in my mind, they're totally ineffective if we aren't using them to iterate towards better availability. And availability is the key metric here. And I'm going to simplify a bit in case anyone out there doesn't agree with me yet. Take any other vital business metric and multiply it by your availability during an outage. How many new users sign up when you're down? How many new repositories are created on GitHub when we're down? And it's none, and that sucks. But everyone has outages. We're running complicated systems, and they're constantly in motion, and they're constantly evolving. So what can we do? We need to study the life cycle of an outage. From the initial trigger to the postmortem, we need to take this information, and we need to learn from it. We need to iterate on our tooling, and we need to iterate on our processes. We need to take steps to decrease the surface area of potential problems so that we can increase our availability even as our environments are growing in complexity. So I really like this quote from Sidney Dekker. He says, "Human error is not random. It is systematically connected to the features of people's tools, tasks, and operating environment." And I find that a lot of outages end up being the result of human error. A bad deploy or an improperly tested config management change, or even failure to do effective capacity planning ahead of time. These are mistakes that we make as people. So how do we learn from an outage, and how do we help prevent human error? So let's start by looking at how humans get involved in this emerging incident to begin with. The trigger's two things. It's the detection of the problem coupled with the notification. Let's assume for now that we've detected a problem and our monitoring platform, whichever it might be, has decided it's time to generate a notification and get a human involved. How can we package the information? What can go wrong? And how are we going to learn from past outages? So we found a couple of things at GitHub. First, alert fatigue is real, so generate meaningful alerts. Fatigue is a serious problem that causes on-call personnel to tune out notifications because there's too much noise and not enough signal. If a computer or a repair process can fix the problem, then why are we generating an alert? Human fatigue is another problem. It's unrealistic to expect anyone to have a quick reaction time if they get paged, if they're exhausted or operating without sleep. So use the shortest rotation schedule that you can. On the ops team at GitHub, we've set up our first responder tier with only 24-hour shifts, and I'm really hoping that as we continue to grow, we can shrink that even further. Everyone poops. Deal with it. You can't react effectively if you're in the shower or getting a haircut. But with a little teamwork, this isn't so much of a problem. We use a ChatOps command called PagerMe, and that lets any engineer borrow the pager from someone else that's on call for a fixed amount of time. Gives them a break to take a nap or take their kids to school. Be persistent with your notifications. Don't page someone every 15 minutes. Page them once, and then page them again and again and again and again every 60 seconds until the alert's acknowledged. Seconds count here, And it's a lot harder to overlook a notification if it's being delivered over and over again. Escalate quickly. Don't let a dead cell phone battery, or a silenced ringer, or a busted cell phone tower turn into an outage. If the on-call engineer doesn't respond, then by all means, wake someone else up. Be loud. Alert over different mediums, tell your chat room that something's broken. Page people's phones, send emails, wake people up. But always try to inform as many people as possible that something else is wrong, just in case someone can't respond. And create handoff reports for every on-call shift. Make sure that these recurring things, these themes that occur in our pager systems, that they don't get overlooked. You know, we have chat ops for this too. We've got a very creatively titled command called handoff. And what it does is it looks at the alerts in your system that occurred in the last 24 hours, and it organizes them, and it graphs them, and it puts them in a GitHub issue. So when my shift is over, I'll pull this issue up, and I'll add a bit of annotated information to it. Just some notes, you know, how the system was doing, what's going on. Try to keep everyone else aware, so when they're next on deck, and when they come onto the rotation, that they're not going to be caught off guard. So back to the outage lifecycle. We've been clued in effectively that a problem exists, so let's look at our initial response. This is usually a somewhat expensive context switch for whoever's first on the scene. They need to establish command, they need to identify how severe the problem is, and they need to do it quickly so corrective actions can be taken before things get any worse. So this is an actual alert. The notification that we see in chat gives us a graph of the problem. And we thought this was a really great way to sort of make that context switch from sleeping or coding or whatever else you might be doing just a bit less painful. Again, the pager command is our gateway into our notification system. With it, we can review alerts that are in progress, we can acknowledge them, we can escalate them, we can even just resolve them. But importantly, when you run pager ack in an ops chat room, you're not just acknowledging the alert, you're signaling to everyone else that sees that you're in charge of taking command of the problem. Now the next function you've got to perform is to figure out just how severe the problem is and who's being affected. Some alerts indicate a serious problem and we'll go straight to warning status, but a lot of them aren't so obvious. What we do is we lean heavily on our monitoring and our tooling to guide us here. In order to be effective, we have to approach this in a way that can be iteratively improved. At GitHub, we have this really strong culture of working together in chat to solve problems. We also make this pretty cool website that lets us collaborate on the software itself. So naturally, we want to use these things when we're developing our interactions with our monitoring system. So let's take a quick look at how we gather data at GitHub, how we present it, and how we interact with it. So for starters, these are graphite graphs. We've got 5 machines dedicated to this task with 80 CPU cores, 640 gigs of RAM, and 10 terabytes of solid-state disks. It's really important to us. So our server-level metrics are typically gathered by collectd, and they're being sent back to Graphite. We use a bunch of open-source plugins to cover the basics like disk utilization, or CPU, memory, network protocol statistics, and so on. And we've also developed some of our own plugins and a whole handful of exec scripts just to parse out and report on information that's more specific to our environment. Application level metrics are instrumented with statsd. Statsd is super powerful. It's this awesome way to sample real-time events and record statistics. There's client libraries out there for just about every language, and it's incredibly developer-friendly. When I checked this morning, we were handling nearly 4 million statsd messages per second. You know, other metrics can be more tricky, because the appliances and the devices that we have in our environment aren't always capable of emitting statsd, and they're not always capable of emitting graphite. So to bring them together, we use all these different tools. For our network devices, you know, we use this cool little tool called Evenflow, which actually was written by Jason Dixon himself. I know he's somewhere in here. That parses SFlow and it ships it back to Graphite. We also have some internal tooling that helps us poll SNMP or poll HTTP, or really pull anything that we can wrap a JavaScript function around. So we have all these data sources, and we're hammering this graphite cluster with about 175,000 graphite updates a second. Graphite is an incredible workhorse. It's a huge part of our metrics culture, and we leverage it accordingly. I also really love talking about it, so if you guys want to chat about scaling graphite, please come find me later. I'd love to do it over a beer. We've got a pretty robust logging infrastructure too. We feed data into Splunk. I work with a fantastic engineer, Kurt Michael, who wrote a library called Scrolls that makes pulling application logs out and putting them into your logging pipeline much simpler. So combine that with some syslog-ng tricks and a couple of other things, and we've got this pretty cool logging infrastructure that's doing about 1 terabyte of indexes a day. So to round everything out, we've got a number of smaller, more special purpose data collection and visualization systems. These sort of fill the cracks and the gaps, and they provide coverage for things in our environment that are more specific to our business. But at GitHub, we don't consider any of these tools ready for production unless we can interact with them in chat. As an engineer is querying different systems during an incident, that person's working in a shared communication space. Everyone present can see everything going into the decisions that this person is making. This does mean that we're writing code to interact with our data. But when we write code at GitHub, what we're really doing is creating opportunities for collaboration, opportunities to iterate, and opportunities to improve. So create tools to integrate your environment. We've got wrappers like GraphMe, which renders the graph in graphite. It saves the resulting image on a server, and then it just drops it into chat. We can tell GraphMe what time range we're interested in and add extra parameters to it. And the graph in chat that you see right there actually links back to the editor itself, so you can do a bit of ad hoc exploration, change queries, and save them for future use. So managing metrics in Graphite kind of sucks right now. I mean, it's 2014, and we're still using Next.js. So to make it a little bit less painful, you should add some tooling around that. Metrics are kind of like cats. So I created a couple of binaries that'll help you herd them around, regardless of how your cluster is designed. So use building blocks like this, and create chat ops to search your metrics using fancy things like a regular expression, or do more complicated things like bulk rename or bulk deletes. We also have tooling to work with Splunk, or our Arbor device, and even Nagios. You know, I could easily spend the rest of this talk just telling you about some of these tools that we have, and we'll have barely scratched the surface. So instead, go look at the Hubot scripts repository, or go watch some talks by Jesse Newland or Josh Nichols. But the takeaway here is that you need to accept the processes that emerge through your culture and through your experiences, and then adapt these tools to augment those processes, and not the other way around. So enough about that. Let's get back to the outage lifecycle. At this point, we've been informed that something is wrong, we've established command, and we've oriented ourselves to the problem. So now it's time to take action and fix things. Like every other step in the outage lifecycle, if we want to iterate towards less risk and better availability, we have to think about how we make changes to our system. How can we build collective knowledge? How do we create feedback loops, and where can we put them? How can our tools build confidence? The best way to explain some of this is probably to look at a real example of an outage. Sometime in the fall last year, GitHub was hit with a few denial of service attacks. It pretty much sucked. So let me tell you about one of them. If we look at this initial alert coming into chat, you can see a couple of things. We've got an issue being created in a repository called Nines. One of our engineers, Aman, was in the ops chat room at this time, and he saw that, and he said, you know, that doesn't look quite right. Let's see what's happening. So we took a look at the current traffic. That big blob of inbound traffic that looks like it's growing is definitely not normal. So what he did is he confirmed the denial of service, and he generated another alert. And that's kind of what I meant by being loud. When things are busted and action needs to be taken, it's super important to get the word out. And it worked. He got my attention. Furthermore, as soon as I joined chat, what happened is I could see the information that Amon had pulled up, what he'd been looking at, and sort of the triage steps that he had already taken. This particular incident happened while we were still getting the hang of mitigating distributed denial of service attacks. We'd already learned a lot, and we were starting to build better alerts and more reliable tooling to help us deal with them. So back to that nines thing. All of our alerts create an issue in our nines repository. The issue is created by Hubot, and it's pre-populated with context around what triggered the notification. In this case, our traffic management system detected an anomaly and generated an alert. In the issue body, we add a link to a playbook for that specific issue. Our playbooks live in Git, and we render them both on GitHub and offsite, just in case. They outline common triage patterns, and they give us procedures for bringing the system back into balance, and tell us who to contact if we need to find a subject matter expert. Playbooks are awesome. They're such a great way to codify your emergency response processes and your standard operating procedures. We're constantly using feedback from this outage lifecycle to grow and enhance our playbooks. They let us institutionalize knowledge. They also provide examples of how our operational tooling works. So the more that we learn, the better our playbooks become. Distributing knowledge and training people on how to operate parts of your infrastructure can be really difficult. So create tools to do your job. If you find something that's broken, then you can use that knowledge to add monitoring coverage. And as you fix problem and uncover the nuances of any system, you can use that expert knowledge to build tools to hide the fact that all software is horrible. Modern infrastructures are really complex, and they're usually built from dozens or hundreds of individual services. And you're quickly going to hit this scalability limit if everyone on the team is required to know everything about every single service and every single network cable and every single process running. So build tools to hide the terrible parts of the software we have to operate. Make them safe for less experienced engineers, and document them in your playbooks. In this case, I knew it was time to bring up some serious defenses. And serious chat ops can be kind of scary. So we've learned to treat actions like this that can't easily be aborted with a lot of respect. And we always require confirmation before continuing. So when I ask Hubot to bring up our shield generator, he asks me a question to make sure that I really mean that. So I repeated myself with the confirmation token, and I let Hubot do all the work. This is super powerful because the process to enable DDoS mitigation like this is really complicated, and it can require some pretty specific timing. And at 3 in the morning, I don't really want to risk making a typo on a border router or forgetting some small but incredibly crucial step. So we've trained Hubot to safely get the job done. And once Hubot's done and the attack traffic has been mitigated, then we can fall back to our monitoring platform and the tools we have there. We can verify that the actions we took had the expected result. So in this graph, we can see that the DDoS traffic hitting our border has vanished. And GitHub is arguably safe. We can also see a couple other things. Specifically, the monitoring platform did a really shitty job of recording data during the attack. And it definitely took longer than we'd like to fully mitigate things. Which brings us to the last part of the outage lifecycle. We need to close the loop. We're not done when the outage is resolved. We have to bring together all of this information about an incident, and we need to persist it so that we can guide every iteration towards better availability and reduced risk. Document everything, anything that jeopardizes your availability. So we review our chat logs, and we create timelines of the event. We link the graphs that we saw. We build supporting evidence. Fairly typical postmortem stuff. And we've dedicated a repository for tracking these types of issues. This is our availability repo. So once the issue is created in an availability repo, that's where the collaborative magic really starts. Development teams are going to get brought in. They're going to offer their expertise. Business and support teams are going to come in, and they're going to help communicate what happened to a broader audience. In-depth research happens. Solutions are proposed. In the attack that I just described, we identified a couple of things that really could have been done better. We should have been able to automatically trigger mitigation for that type of traffic. The misconfigured ACL that allowed network traffic to disrupt our monitoring, yeah, that needed to be fixed too. Hell, we didn't even generate an alert notifying someone that monitoring data was being dropped. Sometimes these issues, these availability issues, will result in a public postmortem, but they always result in improvements across the infrastructure to reduce future risk. And this isn't necessarily an overnight change. These issues can remain open for months as we pick apart an outage and address everything we find. We use issue references across repos to link and pull requests back to this availability issue so that we know what they're addressing. And we're only going to close the issue when we're satisfied that things are fixed. These issues are one of the primary ways that we close the loop on an outage, and they're a big part of how we collaborate towards prevention. By studying these outages, we've been able to make significant progress towards preventing denial of service attacks from improving our availability. We're profiling, we're mitigating traffic. We're doing this automatically. Our alerting is so much better. We've expanded our external service monitoring. We're using a tool by Joe Williams called Nugget, and we're doing network monitoring with things like Thousand Eyes. We're also continuously scanning for changes to the attack surface. We're creating issue when changes happen and making sure that we have up-to-date ACLs, and we have significantly increased awareness on things like this. So things are better, but the work is never done. Availability is a huge part of the reason why we build all of this monitoring and why we're creating so many tools. Availability is the single most important metrics to your operations team, and arguably to your entire business. So study the life cycle of your outages and learn from them. Let all these amazing monitoring tools help you, but remember, your tools are complementary to your process and not the other way around. Communication is the cornerstone for effective incident management. You need to leverage the combination of process and tooling to enable confidence. And you should never stop iterating on emergency response. So thank you, guys. Sure. Questions? Yes?
Do you ever have problems with the availability of your tools during your outages?
So the question was, do we ever have problems with the availability of our tools during our outages? And absolutely. That's something that we have been working very hard on. When I mentioned earlier that we have these playbooks, we render them both on-site and off-site. So if for some reason we can't get to our tools, we make sure that there's a back channel for them.
You mentioned a pretty large graphite infrastructure. What are you using for the storage back in there? I imagine Whisper would be well suited to something of that size.
It is actually Whisper. It's Whisper. It's a.
What was the question?
Sorry, the question was for our graphite instance, what is the storage backend that we're using? We use Whisper for that. It is a consistent hash ring with a replication factor of 2 using Whisper and a bunch of tooling built on top of Carbonate to make sure that a single node outage doesn't impact the availability of our metrics. Anyone else? Do we have another one?
When you tell Bebot shields up and it makes a change to your net config, does that get logged somewhere in reference later in the postmortem?
Yes, absolutely. So that's one of the reasons that we use ChatOps for all this, is because ChatOps is logged, and it's very easy to see whether somebody made a change in response to something, or whether they made a change and then maybe pulled a graph to confirm things. It gives us a pretty good timeline of what's happening. So, one more?
If you're fixing a GitHub outage and you need to clone a tool from GitHub, what do you do?
So the question was, if we're fixing a GitHub outage and we need to access GitHub, what do we do? That's a tough question, and that's part of the reason that I'm on the ops team. We work very hard on this team to make sure that our availability is very important. So, yep. Anyhow, thank you guys. I guess we'll see you next time.